Okay, these are the notes over composite figures. On Monday and Tuesday in class, we did two things, composite figures and probability. This is the first portion of it. Okay, so what composite figures are is when they have two or more shapes that we know put together to make a unique different shape. And so this first one would be two rectangles, and number two, you got a rectangle and a triangle. So when you combine the two things together, you get what's called a composite figure. All right, so there's two things we want to find. The first thing is perimeter. And to get the perimeter, we add up all the sides. But to do that, we're missing this measurement and this measurement. Well, we can figure some of those things out. So if we know from top to bottom it's 6 and this piece is 4, we can figure out that this piece is 3 because 3 plus 3 will add up to 6. Likewise, if this whole thing is 9 and this part is 4, this one's going to have to be 5 so that 4 and 5 add up to 9. So now that we know all the lengths, now we can add them together. So this would be 9 plus 3 plus 4 plus 3 plus 5 plus 6. And we do that, we get the perimeter, which is, hold on, I'm reaching for my calculator. Not prepared for my video. TV timeout. I apologize. Okay, it's 30, even though I can't grab my calculator. Okay. Okay, we'll just call it good. Okay, this is 30 centimeters. I apologize. Now to find the area, we're going to have to take this shape and divide it. So I can divide it horizontally or I can divide it vertically. I'm going to go ahead and divide it vertically. So now I need to find the area of both rectangles. Well, this first one would be 5 times 6, so it's 30. This other one is 3 times 4, so it's 12. So to find the area, I'm going to have 30 plus 12, which gives me 42, and area is centimeters squared. Now, when they're nice whole numbers, those answers are just exact, and we don't really give an approximate answer, but sometimes they're not going to be that way. So we have to come up with another plan. Okay, on number 2, I've got, if I'm doing the perimeter, I can say the top is 6, the left is 5, the entire bottom is 14, and I know it's got to be the whole thing because it's bigger than the top because 14 is bigger than 6. And then I don't do this dash line because that's inside, but I do need this slanted line here. Well, the way I'm going to figure that out is because this slanted line is part of a triangle, a right triangle to be specific. So let's think about what we know about this right triangle. This entire thing from left to right is 14, and this piece is 6. To make it work, this would have to be 8. And the dash line is going to be 5 to match the one on the left. So now I got to find the slanted side. So to do that with the triangle, if you know 2 of the 3 sides, we're going to do Pythagorean theorem. So I'm going to have 5 squared plus 8 squared equals x squared. And so when we put that into our calculator, we'll do 5 squared plus 8 squared because they're on the same side of the equation. And we do that, we end up with x squared equaling the square root of 89. Now, if I put that into my calculator, that's going to give me a decimal. But we need an exact answer, which is, whoops, no decimals. Okay. So the only thing we're left to do is to simplify this radical, but nothing goes into 89. So we're just going to leave x as the square root of 89. So that is what this piece is. So now when I'm adding them together, 6 and 14 would give me 20 plus 5. So I get 25 plus the square root of 89. And this label would be centimeters. Now, to get the approximate, you got to go to your calculator. And if I go to my calculator, I'm going to do 25 plus the square root of 89, and then hit enter, and we're around to 2 decimal places. So I get 34.43. All right, now to get the area, we're going to divide it into 2 shapes. So the area is going to be the rectangle plus the triangle. Well, the rectangle is just 5 times 6. The triangle is 1/2 base times height. Remember, you will have your formulas, so that's Just something you're reading off the sheet. Okay, so base and height are always forming a right angle. So it's these two that have to be the right angle. So this is 5 and 8. Okay, so now when I simplify this, this is going to be 30 plus half of 8 is 4 plus 20. And so that gives me 50 centimeters squared. Now, because that is just a whole number, we don't end up having an approximate number. It's not going to happen all the time, but it will happen occasionally. All right, let's check out number 3. So to find the perimeter, we're going to have to add up all the sides. So I'm going to add 15 on the top, 10 on the right, another 15 on the bottom. I do not add this 10 because it's in the inside. I only add the outside. Plus, now I've got to figure out how to represent this curved part. Well, this curved part, it's like a circle, but it's not a full circle. It's a half a circle. So I need to take half of something. Well, if I'm finding perimeter, perimeter and circumference are the same thing. Circumference is for circles, the distance around a circle. Perimeter is the distance around an object. If it's combination, you just say perimeter. Okay, but circumference is pi times diameter. And we can see right here, the diameter of our circle is 10. So it's just going to be 10 pi. And remember, we always put the number before the pi. All right, so if I'm simplifying this, 15 and 15 is 30, plus 10 would give me 40, plus half of 10 pi would be 5 pi, and then my units would be inches. Okay, let's put that in our calculator. So we're going to do 40 plus, and then we need 5. The pi button is over here below the clear, above this little caret key. So we hit second and that key, and that gives us the pi, and then enter. And we get 55.71. All right, now for the area. Same idea as the ones before. We're dividing it into two shapes. We're going to have the rectangle plus the half of the circle. Well, the rectangle we're going to find by taking 15 times 10. And if you write 10 by 15, that is the exact same thing, times half the circle. Okay, well, the area of a circle is pi times the radius squared. I don't have the radius, I have the diameter, but the radius is always half of that, so it's just 5 pi times 5 squared. And 5 squared is 25, so this is half of 25 pi. All right, let's simplify this. 15 and 10 is 150 plus half of the area. Oh, geez. Okay. This is exact, so there's no decimals. So instead of saying 12.5, we're going to say 25 pi over 2. Now, I didn't point this out earlier, but with the perimeter, 40 and 5 pi are not like terms because they both don't have a pi. So we can't add them together. Same thing with the area answer. Let's see if we can put this in our calculator because there's some new skills involved with that. So I'm going to take 150 plus, and then I need a fraction. There's lots of ways to get the fraction, but the most common one the Algebra 2 teachers use is they're going to hit the green alpha button and then the y equals button. And when you do that, you get a menu. And the first menu item is numerator of denominator. That's what we want. And so we're going to hit enter. And the top of the fraction, we'll have 25, and then we'll use our newfound pi button. Now I need the 2, but it goes on the bottom. So I'm going to arrow down and then get the 2 and hit enter. So I get 189.27. And these labels would both be inches squared because they're area. All right, let's try the next one. This one again is just two rectangles. So let's see what we can do. First, let's find the question mark. Well, if this whole thing is 7 and this piece is 4, to make it work, this would have to be 3. And this whole thing is 8. If this is 5, to make it work, this would have to be 3 as well. So when we get the perimeter, we're going to have 5 plus 7 plus 8 plus 4 plus 3 plus 3, and that will all equal 30 meters. To get the area, we're going to have to break it into two rectangles. And again, you can do a vertical line, or if you wanted to, you could have done a horizontal line. Same deal. If I do it vertically, the rectangle on the left is going to be 5 times 7, which is 35. The one on the right is going to be 3 times 4, which is 12. So to get the total, I'm going to add the two together, and that gives me 47 meters squared. Okay, next one, I've got a rectangle and a triangle. Okay, so to find the perimeter, I have to add up all the sides. Well, I know this missing one on the left is 10. The problem is this one right here. I don't know that measurement, but we can figure it out, just like we did on number 2 in the front. We can draw on our line, so we can create a triangle, a right triangle more specifically. I can't figure out this one yet, but if this top or the whole top side is 17 and this portion is 13, this would have to be 4 to make it work. So the way we're going to find it when we have two of the three sides is Pythagorean theorem. So I'm going to do 4 squared plus x squared equals 7 squared. And 7 has to go last because it's the hypotenuse, and the hypotenuse always comes last. All right, now we are going to put this into our calculator, and because they're on different sides, we have to subtract. So in your calculator, you're going to do 7 squared minus 4 squared, and that will give you 33. So x isn't 33, x squared is 33. So to solve, we have to take the square root. Now remember, it's exact, no decimals. So we cannot get a decimal right now. We can see if it simplifies, but 3 and 11, we're not going to have any pairs. So it doesn't simplify any further. It's just the square root of 33. Okay, so now when we find the perimeter, we have 17 plus 10 plus 7. I'm going to do all the straight sides first. Plus 13 plus 10. We do not add the 4 because it's inside. We're only adding the measurements on the outside. Plus the square root of 33. Okay, let me do some mental math right here. This is 20, this is 20, so 40, 57. So we're going to get 57 plus the square root of 33 inches. Okay, let's put that in our calculator to get a decimal. In our calculator, we do 57 plus the square root of 33. We're going to get 62.74. Okay, and this would be inches because it's a length. All right, now let's switch and find the area. So for the area, we're going to have a rectangle plus a triangle. So the rectangle is 17 times 10, but if you put 10 times 17, that is the exact same thing. The area of a triangle is 1/2 base times height. Now remember, the base and the height always form a right angle. So these two highlighted measurements are my base and the height. So one is 4. The other is square root of 33. You can't put them in the wrong order. So when I simplify this, 17 times 10 is 170, plus half of 4 is 2, and 2 times this radical is 2 square root 33. You cannot combine these because they're not like terms. To be like terms, they would both have to have a radical in them. All right, now to get a decimal approximation, in our calculator, we're going to do 170 plus 2 square root 33 and hit enter. We get 181.49. All right, you're doing great, sticking with me. Last one. Okay, to get the perimeter on this last one, we got to add up all the straight sides. So we have a 25 here, we have a 25 here, but now we need the curves. So don't write this down just yet. I've got a half a circle on the left, plus I can add another half a circle on the right, which will work and get you the correct answer, but it's not necessary. If I've got 2 half circles, I really just have 1 circle. And when I want the distance around, okay, I don't want the area in the middle, that is circumference. So the circumference of a circle is pi times diameter, which this time the diameter is 15, so that gives me 15 pi. Now last time I cut it in half, but last time I only had a half circle. This time I have 2 halves, which is really a whole. So my perimeter is going to be 50 plus 15 pi yards. Okay, let's put that in our calculator. We have 50 plus 15 pi 97.12. All right, almost done. Now let's knock out that area. So for the area, we're going to have a rectangle, and I could add two half circles on either side, but not necessary. Instead of adding two halves, I'm just going to add one whole circle. Okay, so the area of the rectangle is 15 times 25. And again, 25 times 15 would do the same thing for you. Now I need to do the area of a circle. Well, the area of a circle is pi times the radius squared. Well, right now we know the diameter is 15. And on the last one, when the diameter is 10, we divide it by 2 to get the radius. So my radius is going to be 15 divided by 2. But that does not go in evenly, and we want exact answers, which means no decimals. So we can't leave it as a decimal. We have to keep it as a fraction. So that's going to be pi. I'm going to write it over here for a little more space. That's going to be pi times 15 halves squared. And again, I'm not doing the half because it's two halves, which is a whole. Okay, so when I simplify this, 15 times 25 is 375. Plus, now I got to do this. This looks ugly and hard, but it's actually not that hard. Square a fraction, you square the top, square the bottom. 15 squared is 225 pi. On the bottom, 2 squared is 4. And that weird answer is your exact answer. Now, this will not happen a lot. It's only when the radius is an odd number. Or I guess the diameter is an odd number. I misspoke. Okay, let's put this in our calculator. We got to practice doing that fraction one more time. So we have 375 plus, and now we need a fraction. And again, to do the fraction, we do alpha y equals, and the first option, and then we need to put in our fraction. Our fraction was 225 pi, and now I need the 4, but the 4 is in the denominator, so I arrow down, do 4, and then enter, and there's my answer, 551.71. Okay, and then we've got another video coming on geometric probability.